Okay, I'm recording for Trey because he's not here today. We're going to start with worksheet 10B. This is just an easy warm-up. What goes in which of these spots, guys? Vocabulary. Top right?
Top left.
Top left. Okay, that one's the hole. They're kind of tricky because you can't really tell what the arrows are.
The bottom one is the vertical asymptote.
Yes, there is a vertical asymptote here. Well, not there, but here. And so we're going to write that there.
Top right is rational function.
Yep, this one would be rational function. And then in here somewhere is the horizontal asymptote. Okay? This is just practice. If Brenton never writes it down, it's not the end of the world. But this was worksheet 10B. This part, if I were you, I'd write down just because it reinforces. How do you find all these things?
Look at your yellow sheet.
Okay? How do you find a hole? When do you know there's a hole in the graph? Okay, wait a minute. It doesn't have anything to do with horizontal asymptote. There cannot be a vertical asymptote at the same place. There's either a hole or a vertical asymptote there, but a graph can have a hole at one spot and a vertical asymptote somewhere else. Okay, I don't know if I said that in a misleading way before. I apologize. Okay, John, what were you going to say?
I was going to say a hole is when a binomial is a factor of the numerator and the denominator.
Perfect. Vocabulary, there's a common factor in the numerator and the denominator. I don't know what that says. Pretend it says numerator. It does, the factor does have to be of equal multiplicity on the top and the bottom, but I didn't give you any that aren't, so it's not something you really need to be concerned about today or in this class. When is there a vertical asymptote? Faisal, what'd you say? Vertical asymptote? Here. When there's a factor that makes something that makes the denominator, I'm going to use the word only, because it can't also make the numerator equal 0, right? But makes the denominator 0. Horizontal asymptote. There's 3 different cases. What are they? Top heavy. What happens when it's top heavy? There is no vertical asymptote. Or no horizontal, sorry. We're going to talk more about what there can be in a minute down here. Bottom heavy is what? Yep. Now, what does it mean top heavy, bottom heavy? Okay, it is the degree of the numerator and denominator. Is everybody okay with that? We don't need to write that down for a good time? All right, what does that leave? Equal weights. When the degree of the numerator and denominator are the same, then it's what? Y equals leading coefficient over leading coefficient. What's wrong? It's not. Do I have those backwards? Wow, I didn't know I did the top and then the bottom, or the bottom and then the top. Yes, this is not part of the homework check, no. All right. On the quiz next week, it does say, at one point on the quiz, it does say, find the end behavior equation. The end behavior equation can be a horizontal asymptote, it can be an oblique asymptote, or it can be a function of some kind, okay? So the end behavior, all of these lumped together are called end behavior. I don't know what that little squiggle is, but it's supposed to be something around all those saying that's the end behavior. All right, does anyone know when there is actually an oblique asymptote? It has to do with what? Okay, so when it is top heavy by a degree 1 more than the denominator, okay? When the degree of the numerator is 1 greater than the degree of the denominator. Then there's an oblique asymptote. So if we had this, x squared plus 6x minus 3 over x plus 5, that would have an oblique asymptote, and we could find it by synthetic division. Does that sound okay? Okay, we're going to practice that in a minute, so I'm not going to bother to do this exact example. Any other questions about what? Oh, you know what? I want to do 2 more things really super fast. How do you find the zeros? Or they're also called x-intercepts. Numerator equal to 0. There can't be a hole there, right? So you can cancel the whole business before you do the numerator equal to 0 thing. And then how do you find the y-intercepts? Yep, you put in x equals 0. All right, and all that is right on the gold sheet, right? Okay, and you get to use the gold sheet on Tuesday's quiz.
Yes, ma'am.
I have not decided about Friday's test yet. We'll see how it goes next week. All right, I am moving on to worksheet 11. I apologize, this is a really old, nasty worksheet. It's not a nice copy, but I didn't take time to retype it. These are some examples. Please participate. Please write some of these down as examples. I did not put this worksheet on the homework check. If you learn better by just paying attention and participating than writing it all down, I'm okay either way. But don't be working on your A-push or your Spanish or whatever. I'm doing these examples so that you will be able to do your homework. Yes. Do you need a drink? Yes. Everybody okay? All right. I'm going to call on some people. I'm also not going to make you do interval notation here. Let's just start out together on this one. Domain, anybody? X cannot equal what? -4. Okay, 0. Yes, when you set the top equal to 0, you get 7/3 0. I almost wrote it backwards. On the quiz, it asks for you to write these as ordered pairs, okay? Y-intercepts. Nicely done. Okay, you put a 0 in. Vertical asymptote, denominator equals 0 at. Okay, can I just write -4 on that blank? Only if I want to lose some points, right? Because it has to be an equation of a line. X equals -4. Puncture, guys, is, we usually call it a hole now. When you get to calculus, they'll call it like a point of removable discontinuity or something fancy, okay? It's a hole. Is there a hole on this graph? No. Okay, this is what I'm telling you. End behavior equation is simply horizontal asymptote or other, okay? This one is equal weight, right? So equal weight means y equals leading coefficient over leading coefficient, or just y equals 3. Okay? So in this case, it is a horizontal asymptote. I'm lumping it all together to call it an end behavior equation because sometimes it's oblique, sometimes it's a parabola shape at the end. But if I tell you that, then I've given away half of the issue. So I'm just going to lump it all together and say end behavior. All right. Is that all we need? Okay. y equals 3. Crosses somewhere, the y down here somewhere negative, the x somewhere positive. Okay, what do you think? Yep, I'm seeing, that looks right to me. Now, whenever there's a vertical asymptote, it splits the graph into two pieces. Okay? So there has to be another branch to this. Anybody have an idea? Yeah, we got to go to the calculator. That's all good. That's what you're supposed to do. I cheated today. I typed them all in. And I've been turning them on and off as we go here. Oops, I didn't leave that one off though. All right, so it is it this one? 3x minus 7 over x plus 4? Okay. In a standard window, this is what I see. Is that enough to help me do this question? No. Actually, I think it's probably enough to give me an idea, right? I definitely could change the window over a little more negative and maybe a little higher or a lot higher. It doesn't matter. It's up to you. But there's a piece up there in that quadrant that I can't really write in on my paper because it's out of room. Right there, right? Everybody okay? No, because you ran out of room? If you don't want to sketch these, or if you want to just wait till I'm done and sketch something, I'm okay. Any questions though, guys? Seth, did you have a question? Okay. What's going on here? When we're all done with this one, you're going to wish I put it on the quiz. You take a 2 out. Remember, that's what it says at the top of your gold sheet every time is... Now what? X cannot equal -2. What does it have at -2? It has a whole. Because it's a common factor here and here. Okay? We can find the ordered pair, and we'll practice finding the ordered pair, but on the quiz, as long as you tell me the x value where the hole is located, I'll be happy. All right. The whole means that it's not in the denominator either, but now what can I do? I really can factor that out, and what's left? Y equals 2. Guess what this looks like? Y equals 2 with a hole at -2. If I put a -2 back in here, it doesn't work. If I cancel this, it says y equals 2 all the time. What's the end behavior then? What is it looking like on the far left and far right? Y equals 2. It's equal weight over equal weight, right? I mean, it's equal weight, so it's leading coefficient over leading coefficient, if I'm trying to speak English. All right, did it have a vertical asymptote? Did it have a 0? 0 is an x-intercept, and it doesn't have one. Y-intercept? Yes, when you put in a 0, you would get out a 2. Crosses up here at 2. Okay. You agreeing with me now that we've done that one that you'd like one of those on the quiz? Yeah. Yeah, nice thought, but there isn't one on the quiz. Okay, sorry. All right. Guys, the quiz has 3 graphs, I think, and the chapter test has only 1. All right. What's happening here? What's the first thing on the gold sheet say always do? Okay. I'm going to call on some people this time. Brenton, what are the domain restrictions? Good job. Donovan, where are the vertical asymptotes then? X equals 4, x equals -4. Michaela, is there a 0? Good job. Evan, is there a y-intercept? So when I put in a 0, what do I get out? Look here. When I plug in a 0, what do I get? There we go. It's a disgusting answer, but it's what I want. Is there a hole, anyone? End behavior. Sam? Y. Yep, bottom heavy, so y equals 0. Good job. All right, so how many parts does this graph have? 2 vertical asymptotes means there have to be 3 parts to this graph, okay? Something in between, something on the left, something on the right. Some of the graphs on this worksheet, we're going to have to do some crazy window manipulation to find pieces of the graph. On the quiz, I made sure that you could see at least a hint of each part of the graph in the standard window so that you didn't freak out and forget whole pieces, okay? Yeah, well, you know, it happens. It's because I hate grading things when they're horrible, right? All right. I have graphed this one. No. I'm afraid if I made things really, really hard that the grades would be horrible and then I would cry when I tried to grade them. That's what I'm saying. Okay. Zoom 6. This is what I got. I found this very hard to tell what was going on. Okay. I tried something that worked out pretty well last period. If you go to y equals and arrow to the left until you're in front of the y, you can change the thickness of that line. And this graphed it in a bold. Watch carefully as it graphs it. Do you see where the 3 parts are? Okay, so over to the left of -4, what's it doing? Yeah, it's all down here, isn't it? It's doing this. What's it doing in between -4 and +4? Like a cubic-y thing, right? We have some intercepts, don't we? Crosses at -3 over here, and down here at negative decimal. Yeah, -3/16. Oh my goodness. Do you like it? Has a little nose over there or something? I don't know. It's kind of goofy. And then it's up here, right? And looks like it ran into trouble over here. All right, are we okay? 3 parts. That's all I gotta do is a rough sketch. All right. Oh dear. Now what? Factor. Go, go, go. Factor. What do we get? That's what I heard from someone, yes? And take out a 3, that gives you an x, or 2, sorry. That gives you an x squared minus 9, which factors x plus 3 and x minus 3. I was trying to save time by not writing it out too many times. Anybody figure out the denominator yet? Is that what you said, Alex? Not sure if that's what you said, Ben. Is that right?
Yes.
Okay. Everybody agreeing? Okay. Jacob, tell me the domain. X cannot equal... That's good. Nope, you're good. Okay. Other Jacob, where are the zeros?
Negative 3, 0. And 3, 0.
Abigail, is there a y-intercept? Go back to the original. It's much easier. If you put a 0 in back there, what will you get? Yep, negative 18 over negative 2 is 9. Nicely done. Vertical asymptotes, James?
X equals negative 2 over 3. X equals 1.
All right, Alex, you get a break. Are there any holes? Tough question. End behavior, Crystal? Equal weight, top heavy, bottom heavy. And what does that mean? Yes, y equals 2/3. Great job. All right, are we done? Y equals 2/3. X equals 1. I'm going to space that out a little bit because I think there's got to be something in between that x equals 1 and over here at x equals negative 2/3. Wow, those are straight. Yeah. It's that cocktail I had for lunch. It did me in, right? All right. We have some zeros, though, right? Some more things to help us figure out what's going on. Up here, it crosses at 9. Over here, it crosses at negative 3. Over here, it crosses at positive 3. That gives me some hints about where things are, right? Okay. When I have all that on the graph, then I'm probably in pretty good shape for graphing. Okay, in a standard window, this one is a stinker in a standard window. Look what happens. Can you tell what all's going on? If you were a little careful, you might at least see a hint up at the top. Right? There's a little hint that something's going on up there at the top. And we knew we had a value at 9. Okay? But I'm thinking this is happening over here. And this shape over here. It does definitely cross the x-axis and then stays, I think, below 2/3. All right. But there has to be something going on between those two asymptotes. I think it's up above, do you think? Since we had a 9 up there. So if I change the y value to like 20 or even 15, what's going on up there? A little parabola shaped thing up there somewhere. And I really don't care that you have to be super picky about it. Okay? Yep. As that's why most of the time I will ask you all these things that you have to write them out. The ones on the quiz are pretty straightforward. You should be able to be halfway accurate, okay? All right. Everybody good with that one? Oh, I want to talk about this. I want to talk about, in case of both of these, guys, this is a big hint for Monday. Everybody looking up here? See the green? On either side of this red asymptote, one side of it, it's going up, one piece is going down. Do you see that? On the other side of the red asymptote, one piece is going down, one piece is going up. Yes? On this one. Let me see. If I point with my eraser, that won't be a good plan. It'll erase it. I don't know. Is there a little like light you can turn on? I can turn on a highlighter, right? Thank you. Okay, thanks. Yeah, over here, do you see it's going down? Up here, it's on either side of that asymptote, it's going up and down. Over here, going up. Over here, going down. It always will go opposite directions, the two pieces on opposite sides, unless the asymptote itself happens to have a squared around it, like the factor in the denominator had a squared. Then both sides on either side can go up or down. That's a hint for Monday. All right, I'm moving on. Factor. Factor, factor, factor. Okay, I was trying to factor it without writing that step out. Did I get it right or not? Okay. This is a hard question, harder than what's on the quiz. X cannot equal 0 or -5. Yep, make sure you get both of those. Okay. It has zeros where? X equals 1 and X equals -3. Why is there not one at 0? There's one out here. Should there be a 0 at 0? Or there should be a whole at 0. Because it is a common factor top and bottom of X. Okay, once we've written that down, we're allowed to get rid of it, right? We can factor it out. So now there are only zeros at 1 and -3, and the y-intercept, if you put it back in, you get 0 over 0, which is, isn't that what it means to have a hole when x is 0, is that there's a hole on the y-axis, okay? To figure out where that hole is, you could plug 0 into the new one. 2 times -1 times 3 over 5 would give me what? Yes, if you wanted the ordered pair, it would be at 0, -6/5. As long as you tell me it's on the x-axis, I will be fine. But it does help us to know it's down here somewhere. On the y-axis. Did I just say x-axis? I think I did. Okay. Vertical asymptote? No. There's a hole at x equals 0, so there can't be a vertical asymptote. But this one has a vertical asymptote at -5. End behavior. Oh, this is where I want to cry a little bit. It has no vertical asymptote. No horizontal asymptote. Okay. We have to divide. Guys, if you look on the gold sheet, I think I have it open. If you look on the gold sheet, look at the bottom. End behavior or oblique asymptotes occur when you take y equals the quotient that you get when you divide p by q, ignoring the remainder. Okay. You could do this one 2 ways. The hard way would be long division from the beginning. Okay? The easier way is, once we've factored that x out and it's gone, we can do synthetic division. We have a -5, but you got to factor this back together or something. Let's just go back over here, guys. Go to this one. If you took an x out of everything, you'd have 2x squared plus 4x minus 6 all over x plus 5, right? This is really what we need to divide, okay? There's a minus there. So across the top we have 2, 4, and -6. Bring down the 2, multiply, add. Do I care what's over here?
No.
It said ignoring the remainder. So what is the end behavior equation? Y equals 2x minus 6. Okay, 2x minus 6 looks like that. I'm just making something up, okay? Y equals 2x minus 6. There's our end behavior. There is a vertical asymptote somewhere, though. Where? There is a hole on the y-axis, but there are zeros where? 1 and -3. So I'm guessing there's a piece over here. What do you think? Any ideas where that other piece might be then? Because there's a vertical asymptote, so there has to be another piece on the left side of that green line. Can it be up here? Probably not, because it's got to be going down. All right, go to your calculator. This one is not in our standard window, not even close. See if you can figure out where it is. In the standard window, all I get is the top branch there. There has to be something going on to the left of -5. So I could change my window to the left a little further. Do you think I need to go up higher or down further? Down. I only know this because I've done this problem 20 times today. You have to go down far. I'm going to do like -50, okay? I could take my time and do it in increments, but you really do have to go down. The piece is down here, and it's like at -30-ish is where it starts doing this slice. All right, not on the quiz. There could very well be, there is one on the quiz that is this general shape, but it's not that far down off the bottom of the window, okay? Yes. You want this gone? You got what you want? Anyone else? All right, is there one more? Lordy, lordy. Okay, what are we going to do?
Factor.
Take out, factor the bottom, factor the top. What do you notice right away? There's a hole at x equals -1. The domain cannot include 1 or -1. Only after you've done those two things can you cancel that factor. Oh, now I think we're in good shape. All we have left is 3 over x minus 1. So does it have a 0? Can the top ever be 0? If I plug in a 0, what will I get out? Is there a vertical asymptote? Okay, at x equals 1, there's an asymptote, but at x equals -1, there is a hole. Can you find the ordered pair for me? If I put in the -1 to this new and improved reduced fraction, what will I get out? -1 minus 1 on a good day is -2, so I get -3/2. -1, -3/2, there's a hole over there. Okay, it doesn't ever cross the x-axis. End behavior? It's bottom heavy, so it's y equals 0. It does cross over here at -3, or down here at -3. So I'm thinking all it's got going on is this. Well, pretend I hit that dot. It's a very big dot right there. Do I have to get out the calculator or you got it? All right, because I have to leave in 5 minutes for a funeral. Miss Abruzzo is going to come over, but I want you to please go to worksheet 13 very quickly. Very, very quickly. I can talk some more with your class on Monday about this worksheet. I just want to go over a couple things. The top says determine which are polynomial functions. A polynomial function can have fractions and decimals in it, except in the exponents. It's got to be like x cubes and x squareds and x's. So find one that's a no. 17 is a no. Okay? 18 is a no. All right? If it is a yes, it says state what degree it is. 19 is a yes, guys. I know it's got weird numbers in there, but aren't they all numbers? So it is a yes with degree 4. Okay? It's 15 is a no. It says for those that are not, tell why not. You can cross that out. All right. These are yes or no. Is it a polynomial function? What's the rules? Got to be smooth, continuous curve with no breaks and no sharp turns. Okay. It has a break. It's not asking if it's a rational function, like if it has an asymptote or anything. It's asking a polynomial function. So no. It doesn't, it's actually probably a piecewise function. But all right, 63 and 64. Let's do 64 and then I'm out of here. Okay. There's one like this on the test, not on the quiz. What can you tell me about writing an equation for this? It's going to have a negative leading coefficient. You're right. It's going to be even degree. Good job. What else?
One of the binomials.
Yep. It's got a multiplicity too here. You guys are good. And we actually write it though? What you got? X plus 1. X minus 1 squared. Nicely done. Everybody okay? Can you get that right on the quiz? Test? Okay. The trick is, and the trick is the one on the quiz, you have to find the stretch. On 61 and 62, you don't have to worry about it because it doesn't give you a Y scale. But on these two, you have to find, we've been calling it A, right? This stretch out here. The ordered pair they give us is this one. What is the name of that ordered pair right there? 0, 1. So if I put in Y equals 1, I can make it a negative. It doesn't matter. It's going to turn out negative. I put in a 0. What do I get? 1 equals negative 2A. So A is negative 1/2. Okay. On the back, I have 30 seconds before I need to leave. I will do a couple of these with you, but on the back, you will need this. I wrote this on your paper for you, didn't I? But I used U's and V's instead. Remember the whole cubing goofiness? Okay? You have to factor all these nasty things. You have to find vertical asymptotes and holes, but you also have to find the end behavior, whether that is a horizontal asymptote or some crazy function that you get from doing synthetic or long division. You with me here? You do not have to graph any of these. Okay? All right, any questions about that worksheet?
Some of us won't be here on Monday for prayers or whatever.
Oh, okay. You're going to struggle with worksheet 14 then. I will tape the lesson. Oh, speaking of which, let's stop this.